Welcome to the next lesson. Case study number 5, generative AI chatbot. Let's get started. Sophia is a junior software engineer. She is working on a chatbot for customer support at a mid-sized e-commerce company. The chatbot will answer common questions, suggest products, and escalate complicated issues to human agents. Sophia needs to define precise requirements to ensure the system works well and is reliable. Here are the requirements she came up with. The system must understand what users are asking and determine what they mean. It should give clear and relevant answers based on users' requests and the e-commerce company product catalog. The system needs to manage varying amounts of traffic while keeping performance high and staying available. It must keep track of the conversation to ensure it stays relevant and makes sense during multiple exchanges. If the chatbot cannot respond appropriately to the user, it should be able to escalate the request to a human agent. All right, let's get into the system. All right, so again, first and foremost, we always have the user as the first thing that we interface with. So now, so that I can get to the user, let me just make sure I put the order, send to back. That should do it. Now, let's go get a user over here. We'll put it over here, the user. Okay, so now we're thinking of, listen, in generative AI chatbot, of course, we're thinking that we'll have some sort of web service of some kind that we interface with in order to talk to this AI chatbot. We've seen these before, so let's go ahead, put this over here, call it a web service. All right, so here's the thought, right? So, okay, we know that we have this web service we want to interact with. We know that and models and services connect to models are going to be very important in here. And we're going to talk about what that looks like in a little bit. But let's look at some of these system requirements. Okay, so first, first two are talking about the model, so that makes sense. I want to actually skip to this last one. No, not the last one, this fourth one. It must keep track of the conversation to ensure it stays relevant and makes sense during multiple exchanges. Here's something to understand about models, LLMs, whatever you want to talk about. They're typically stateless. Actually, models are something like LLM, like models are files. You can download them. They can be anywhere as small as maybe 500 megabytes to as big as hundreds of gigabytes. But at the end of the day, they're files. Why? Because they're a collection of weights. They're vector weights, and weights are a collection of matrices that are a collection of numbers, essentially. It's data. It's data that that we use to put a lot of data to train and generate these weights that are saved in this single file. And this single file is the basis in which how we have generative AI. So it's quite an amazing technology, but then it's kind of interesting that it reduces down to a single file, right? So if it's just a single file, if you're interacting with it, it can only, you basically can only interface with what you give it. So if you have a whole conversation, you actually have to send the entire conversation every single time. If you see lots of other applications and they're showing like the conversation back and forth, they're sending your entire chat every time you interface with any sort of model. So given that means the system around the model needs to maintain these properties. It needs to know or remember all the things that you wrote, not the AI itself. And this is why, system design is important. Gen AI is very powerful, but the systems around it is what gives it the abilities for us to maximize AI potential. In this case, we use the systems around it to make sure that the AI remembers what we were talking about in a single chat. So that to the side. So if that means that we want to save all the chats that we have and then have separate chats, then, you might have guessed it. Good old relational database, good old data layer is very good at doing that. So we have a little service here. we have our data layer service. And one of the structured data that's going to have is about all the chats that we've had with this chatbot, so that when we send subsequent chats within subsequent messages within a single chat, it gets all that information. All right. So we have that understanding here. So now I'm going to say, like, what do we represent these AI, interface with the AI models? But even before I even go in there, let's also think about, the first two requirements here. First says the system must understand what users are asking and determine what they mean, like semantic understanding. And then second, it should give clear and relevant answers based on users' requests and an e-commerce company product catalog. These two requirements are hinting at three things a bit. One, it really wants to emphasize that the system understands what the user is coming from. Maybe even having a dedicated model system that's focused just on that. Then it must give clear and relevant answers based on user requests. Have another one that's really focused on, given the understanding, generate information that makes sense to the user. And then the third part is, based on users' requests and the e-commerce product and company product catalog. There is this third external information that the understanding and the response generation should be based on, should come from, right? So you have these three aspects that leans to maybe three parts of this system that works. So that being said, let's start with one. If I combine, as I told you, that models, AI models, they are just a file. So guess what? We're going to have a service connected to a file store. And what this is going to give us is an NLP service, or natural language processing. We had this earlier in previous case study. We want to have a model that's focused on, getting the information from the user and understanding what the user is meaning, is asking, breaking that down. Now, typical like LLMs can do both, understanding and response generation. But if you really because the requirements have that separate, and there's really a need to really want to maximize the ability of both areas, this is when you can have a separate model for understanding, natural language processing, and a separate model for response generation. That's what we're going to have here. So we have this service here. Then we'll have another combination over here, and we're going to call this, for lack of better terms, this, again, the goal of my naming abilities is not about this is the best name. These are some really bad names. I'm really focusing on understanding, that you understand what's going on here. So I'm going to have this big, long, like a long, cheesy name so you understand it. So this is response generation service. So what this will have a model in of itself who's focused is to, based on the information it gets, with understanding it gets from the NLP service, it can give a response to the user. Now, let me just start connecting. Actually, no, before I start connecting stuff up, here's another thing. There's a third aspect, right? The e-commerce company product catalog. Because remember, when you take a model from, like an open source model, any model, it's been trained with lots of information all over the net and what have you. But what it probably doesn't have is the most up-to-date product catalog for this e-commerce company. Whoever company or whoever created this model most likely didn't find out, ooh, what was that newest price update that happened, 5 minutes ago? It doesn't have that information. How do you get this information there? There's a number of ways of doing this. Now, since this is it's like an AI chatbot, and it's really about understanding, the approach that we're going to use here is we're going to put a vector database here. Okay, I'm going to call this something very long. And you're going to see why in a second. We're going to call it a company knowledge base vector database. And you'll see why in a second. Okay. So Now I like it one word. So hold on, I'm gonna move this down. But here's the idea here, and let me go ahead and start connecting at least some of these things together so you start to see what I mean. Then our view surface goes to the response generation service, but this also still goes to the company knowledge base as well. And the idea here is that as new information change and increase in the company knowledge base, that whatever the company wants this AI chatbot to understand and know, we go ahead and actually run it through another model, which I don't have it listed here, that converts it into vector weights that's saved in a database. Now, the difference between having like the flat file model and this database, if you think about what's the difference between a file and a database. Typically, files are static, likely they might be larger in nature. It depends on the size, but they're static. They don't change much, and they're it's easy to retrieve it as a whole. But to edit and modify different parts is harder. Whereas a database, it's always on. It's easy to add new information to it. It's easy to query for information to it. One thing that vector databases are very good at is be able to query and say like, hey, I have this semantic information, this semantic text. What is similar to what I just put in? So you start to make it can make connections to, the company knowledge base that, let's say, a straight relational database with querying couldn't do. That's what we want, because we want to interact with the chatbot. We want the chatbot to understand as much as possible to answer the user's questions. So that's why we'll have this company knowledge base of their database will be continuously uploaded the latest information of the e-commerce site, converted into vectors, and it's saved here so that not only the NLP service can use it to understand, the response generation service can use it to also generate relevant information to the web service. So this is what we do. Now, the system needs to manage very amount of traffic while keeping performance high and staying available. Here's the thing to we have to consider. If we have a lot of users running and hitting these NLP services and so on and so forth, these things are typically, higher output. They require GPUs instead of CPUs. That there's a lot of processing involved in order for AI to work. One thing that you can do is to manage the availability of a service is that you actually put a queue with some workers in front of you. And let's go ahead and talk about that for a second. What does this mean here? What am I trying to do here? So actually, first before I even talk more, I'm gonna connect all this up. So to start to be more clear how things are connected. Just give me a second. It's always sometimes a little difficult. Oh, give me 1 second. We gotta have this, move this to front. Bring to front, which should allow me to do this. Okay, all right. And I'm actually gonna give you the name. We're gonna call this, so I get this, nope. Here. We're gonna call this user request workers. Okay. Why? This is the cool thing about combining queues with workers. Now, all of a sudden, before I was just like, oh goodness, if there's a lot of users, oh my goodness, here, make sure the web service is connected to the user itself. That's important. When the user is sending requests, lots of users are sending requests, and you don't have anything in between the web service and the NLP service, then it's just going to hit the NLP service directly and the response generation service directly, and it's going to handle what it can handle, and then that's it, right? Now, you can say like, oh, we'll scale it up, have more NLP services and so on and so forth, and you can do that. The question is, do you want to do that? Do you want to have all these things scaled up, and then when demand goes down, then you have all these things scaled up? Now, yes, there's this thing called auto scaling that has the ability to essentially have number of these services and these file store these services up so that it can be responded, we can ramp up and ramp down. But there's a cost to that. And the question is also is like, do you really need this, right? Do we really need absolute availability right now? There's a counterpoint that, let's say when somebody sends in a request, it goes into a queue and a worker takes that queue and goes to the NLP service and goes to the response generation service. Remember, a worker's strength is that it has the ability to independently execute outside of the user's perception or the user's interaction. So this can happen on the side. The user can be told, oh, it's waiting, it's processing, and so on and so forth. Other users can go ahead and send requests, and it will just go to another queue. You can modify the queue and how many workers you have to the maximum output of what your NLP service and your response generation service can use. And so therefore you can actually handle a lot more users than you have processing for, because this queue moderates it. This queue, all the requests are being captured, and as long as the user, and the trade-off though is as long as you have a user experience that tempers the expectations of the client, saying that, hey, listen, it's processing, give it a while, then you have effectively able to manage varying amounts of traffic, and while keeping performance high and staying available. All this is still available, and you don't have to actually scale up and scale down so drastically these rather expensive services. Something to think about, the power of a queue. It really, like, one of the powers of queues is that it gives you the ability to not have to rely on load balancing or scaling up or spinning lots of services to each other. If you can, the trade-off is that if you can create a user experience that makes it okay to wait a bit, then you can actually run the same application with lower hardware requirements. So that's one thing to think about. So that's why we have a user request workers here, because the idea is the user goes in, they send a request, the web server saves the message, then takes all of the messages from that chat, sends it to a queue. A worker comes and takes that queue, runs it through the NLP service that connects to the knowledge base, runs it to the response generation service, and then gets its response, and it goes back to the user. So this is good. We're really, this is knocking off most of these requirements. There is one requirement that we haven't hit yet, right? And what we haven't hit is the last one. If the chatbot cannot respond appropriately to the user, it should be able to escalate the request to a human agent. Here again, this is something that's really important, that is just, especially they want this chatbot to be able to, let's say, give great and semantic understanding and responses to the user, but also we want to make sure that, like, if need be, there is an actual human being that the person can interact with. But we can put this in the system. So this is what we do is, first off, we represent this human agent with another smiley face, because it's a person, it's a human. Well, we're going to give that a name. And the name here is the agent. So this is the human agent. Now the question is, okay, how can we make sure that the human agent is able to help out here? Well, what we do is we take a service and connect it to, if you might have thought about it, a queue, and give this response generation service the ability to escalate there. And we'll connect this to the human agent, and then we're gonna have a name for this service. It's gonna be called the human agent service, right? Okay. Now here's the thing. Now, when the response generation service is generating its response, and it's just saying like, hey, could determine this is I'm not answering this, correctly, I'm not answering this to a high enough level, then it has the ability to use this. And that's the thing. They have the ability to call an external service, like, so they call them tools in some cases, so that we can say like, hey, send a message to a queue, give all the information that you have, the chat, the context, whatever you've come up with, and then this service go ahead and ping the human agent, and the agent can use the service to see what the response is, respond in kind, and then go back to the user. And so notice that we have this service with a queue connected in order to connect to however human agent is there. So in that, now we've satisfied all 5 requirements. We have this ability for the AI separated from with a natural language processing service and a response generation service, have the ability to escalate to a human agent service as well in order to get that human touch when it needs to be and not all the time. You have this vector database that has all the knowledge of the e-commerce platform in vector form so that the models can access it directly. And we have these user request workers that enables us to be able to create a responsive environment without having to auto scale our AI processing. We also have data layer service that helps us save chat as well as save critical data that the web server needs in order to interact with the user. And so now we have our complete system. All right, so let's go to our takeaways. First key takeaway, enhanced AI chatbots have 2 main parts: natural language processing, NLP, and response generation. First, NLP focus on understanding the user's feelings, intentions, and context. Then, the response generation part creates a human-like reply. Both parts use AI models in a file system linked to a service. The response generation service can escalate to a human agent through a queue for further assistance if needed. Here's the second takeaway. The system manages changes in traffic demands by quickly handling failures and allowing users to retry the requests. It uses a queue linked to user request workers to kick off the request pipeline and generate responses by independently executing without making clients wait, which is a worker's strength. Third key takeaway. The database keeps all messages from a chat so the system can send the entire conversation to the AI chatbot for context. Additionally, the company's knowledge base has been turned into a vectors and stored in a company knowledge base vector database. The NLP service and response generation service can answer questions using information from the company's knowledge base. All right. Thank you so much for going through this with me. We'll see you at the next one.